Hi, Geometry. Unit 1, Lesson 17, working with rigid transformations. So we spent 2 lessons in symmetry, and now we're moving back into a little bit more of that rigid transformation and talking about how it affects congruency and shapes and all of that. So let's look at this warm-up. Segment CD is the perpendicular bisector of segment AB. CD is the perpendicular bisector of AD, which means that's perpendicular and those are congruent. Find each transformation mentally. Ooh, I like to draw. So a transformation that takes A to B. So A to B. It looks like I would do a rotation around center M 180 degrees. Okay, I should get to the answer to make sure that I'm telling you exactly what I should be. Oh, another way would be a reflection across segment CD. Yep. Reflection across CD, rotation 180 degrees around center M. They listed both of them. I listed one. All right, number 2, a transformation that takes B to A. Really the same as 1. Yep, cool. Oh, I'm going to add one to this. Okay, we're going to put it in a fun color because I didn't think about it. So a translation from directed line segment AB. So translation by the directed line segment AB. That means a translation along the vector AB. So it would go from here to there. Okay, I'm going to erase that though. And that would mean that number 2 has the same thing, but the opposite direction. A translation along the directed line segment BA. It would go from here to there. Cool. All right, so how about a transformation that takes C to D? So we want C to D. So number 3, you can say a translation along directed line segment CD would take C onto D. I can't do a reflection over segment AB because CM and MD are not the same length. I can't do a rotation around center M either. I could make a perpendicular bisector. Reflection across, if I could spell, perpendicular bisector of CD. So I could make a perpendicular bisector of CD because we know how to do that and reflect it, and that would work. And number 4, need another color. Purple. A transformation that takes D to C. So we can do a translation from directed line segment DC or a reflection across perpendicular bisector CD again. Okay, cool. We were supposed to do that mentally, you know, just in our heads. All right, card sort. How did this get there? I'm going to put a Google Doc in Classroom for you to work through this. Okay, I've said that before, but that wasn't for a card sort. That was for a problem card and a data card, which is impossible to do. But card sorts we can definitely do. So we're going to sort the cards into categories of your choosing. Be prepared to explain the meaning of your categories. Okay, you can just put a comment in the document, and then sort the cards into categories a different way. Be prepared to explain the meaning of your new categories. Maybe I'll put 2 documents in the classroom for way 1 and then way 2, okay? And please put a comment in to tell me what you were thinking about to do that. Cool. And last but not least, reflecting on reflections. Diego says, I see why a reflection could take RSTU to R prime, S prime, T prime, U prime, but I'm not sure where the line of reflection is. I'll just guess. How could Diego see that a reflection could work without knowing where the line of reflection is? How could Diego find the line of reflection? So we need to find RSTU, which they say is in a previous. So I'm going to push pause. I think it's from our card sort. Hold on. All right, here we have RSTU. What Diego said was, I see why a reflection could take RSTU to R prime, S prime, T prime, U prime, but I'm not sure where the line of reflection is. I'll just guess. So actually on this one, there is a line of reflection, and you should never just guess. Okay, the line of reflection is there. We're reflecting over. Don't worry, I'm going to erase this. Okay, but it's not, you don't have to just guess. You can actually find your line of reflection, and this is really, really important. You can find your line of reflection by finding the perpendicular bisector of a segment. So I'm going to go back to what Diego said. I see why a reflection could take the original to the image, the pre-image to the image, but I'm not sure where the line of reflection is. I'll just guess. If you see question number 1, it says, how could Diego see that a reflection could work without knowing where the line of reflection is? You see here I've got RSTU in a clockwise manner and RSTU in a counterclockwise manner. So we know that they all match up with each other because they're in the same order, just reflected in a mirror. But the exact line of reflection is actually quite important. If I connect S prime to S and I find the perpendicular bisector, that's the perpendicular bisector, and I'll name this line L. That means L is the line of reflection. Okay, I can do that with any 2 points. I can connect the image and the pre-image point and find the perpendicular bisector. And that perpendicular bisector is your line of reflection. All right. Let me do one more thing because I want to show you. So I'm going to make a polygon, and I'm going to reflect that polygon over a line, but then I'm going to erase the line. Okay, I think I'll be able to erase the line. I hope I will. Again, I should probably test this. So reflect about a line. Cool. Now I'm going to select this line and I hope, delete it. Okay, we don't have to, it's okay. Watch this. I'm going to trick it. I hope. Maybe. Oh, I have to move my head. I was hoping to color it. Oh. There we go. Now I thought I could make another polygon. We'll see. We'll see if I can delete it this time. Oh! All right. It's okay. Watch this. I'd love to hand draw it, but it's all right. Segment, distance or length. I'm not gonna be able to make a segment exactly 6 inches long or 6 units. All right, let's see. I don't have a way to do this. Ooh, I know what to do. Okay, I got it. So let me get that line back. And I'm gonna reflect it, and I'm gonna cheat. Okay, you still with me? You haven't pushed pause yet, like Miss Carly's lost it. Now I'm going to hide an object. It's gone. All right, so now we're going to practice finding that line. So if I connect my image and my pre-image points, and if you remember how to do this, we need to draw a circle. So I want a circle with center just past center. And then I want to copy this circle to the other side. And where, I get excited when I figure stuff out. Where's the point? Polygons, more. Can never find the intersection thing. Do you guys laugh at me yet? I want where these two circles intersect and those two circles intersect. I already have that. I'm going to draw a line through that. Oh, not there. Draw a line through that from here to there. And we're good, right? Now I could actually, I don't think I can, oh, there we are. There's D and E, which I hid, which were 2 points on the previous line that I hid. So we did it, all right? I reminded you guys how to do perpendicular bisectors. It's your line of reflection. I could have done it through any of these 2 points, and it would have worked great. All right, I just wanted to remind us all how to do that. So that's how Diego would find an exact line of reflection, okay, by finding the perpendicular bisector. All right, good job.